In this session, we are going to study about electronic brake force distribution and a traction control system, which is simply called as EBD and TCS. Overall outline of today's session, we are going to start from learning objective and outcome of the particular topic and why EBD and TCS is required in a modern vehicles and what are the components are involved in a EBD and TCS system, how it works and what are the benefits of EBD and TCS, what are the cars which is available in today's market with these facilities. So our objective and outcome of the today's session is we have to understand the working principle and the importance of electronic brake force distribution and traction control system which is used in a vehicle. That is our main objective as well as our outcome also. Let me start. Why EBD is important? What is the purpose of EBD? What is meant by EBD first of all? The name itself it implies electronic brake force distribution, which means it's the system going to distribute the brake force to each wheels, and based on what it's going to distribute. So here, based on the different road conditions, speed value, loading conditions, and cornering, like taking a left turn or right turn, it's going to distribute the required amount of brake force to each wheels in order to maximize the braking efficiency or for a optimum braking condition. Involved in an electronic brake force distribution system, there are four main components are involved in the system. First one is a wheel sensors, another one is a yaw sensor, next one is a modulator, either a hydraulic brake fluid modulator, and last one is a control module or electronic control unit, or it is simply called as a ECU system. Here, wheel sensor is used to measure the speed of each wheels, and yaw sensor used to measure the vehicle movement along with the vertical axis, and hydraulic brake fluid modulator is used to control the required brake fluid pressure on each wheels. At last, ECU unit is used to receive all the information from all the sensor and to control the units. So how electronic brake force distribution system works? Here, wheel sensor and yaw sensor used to measure the various conditions of vehicle and it sends the information to ECU. While applying a brake, ECU check all the input values and allow the hydraulic fluid modulator unit to supply the required braking force to the individual wheel for a optimum braking. This is how electronic brake force system works. For a further clarification, you can go through the video by clicking the link over here. Here you can see two different cases in this picture, car with EBD, without EBD. In this case, in two different cases, if the car without any loading condition, the brake force applied on the rear wheel is same, but once we loaded the vehicle, the brake force applied on both the cases are differ. It's just because of ECU car with the EBD measures the loading conditions and it applies the required amount of braking force to the rear wheel for the optimum braking condition, but in car without EBD it's not happening here. Benefits of EBD: it can reduce the slip on watery or icy roads during the braking and it can improve the braking efficiency as well as it reduces the strain on hydraulic brake force valve in the vehicles. You can see the cars which is available with the EBD facility, which is Maruti, Ignis, Tata Nexon, Toyota, Etios and Nissan Micra, Ford Figo, etc. We are going to look about traction control system. Before I enter into the topic, you need to understand what is meant by traction. Traction is the force used to generate a motion between the wheel and road. So now, traction control system, it can improve the acceleration of the vehicle by reducing the slipping of wheels on a slippery roads during the acceleration. For further clarifications or to understand more about this topic, just you can go through the video by clicking the link, either you can refer the video resources also. With this picture itself, you can clearly understand the importance of traction control system on a vehicle. It shows the two different cases, car with the traction control system, without traction control system, how it moves on a cornering. Are involved in a traction control system. You can see here, which is having a like a wheel sensors, ECU and hydraulic modulator Along with it, we have a two additional solenoid for a traction control which is attached to the brake circuits. And what is the working principle of TCS? How it works? In traction control system, if the wheel sensor senses one wheel will be spinning more quickly than the other wheels, it sends information to electronic control unit, and again it sends information to the hydraulic brake modulator to say apply the brake pulses on a particular wheel to reduce the speed and spin. By reducing the spin and speed, we can increase the acceleration of the vehicle. For clear understanding, just you can go through the video by clicking the link, either you can use the video sources. You can see the some of benefits of traction control system here. It can increase the acceleration of the vehicle on watery and icy roads, and it can speeding up the on uphill road where the surface appears shaky because of gravels and stones, as well as it's very much useful when the wheels loses the traction due to burying in muddy patch on the road. Which is available with the traction control system in the market. For example, Aricue, Kia Carnival, Mercedes-Benz, Tata Nexon, Maruti Suzuki, Volvo, etc.